Hello and welcome to this Networking Basics 2 content. In this session, we will examine how the traceroute tool works and what its results really mean. If you have not yet watched the video on ICMP, we recommend doing so first, since traceroute relies on ICMP messages to operate. Let us begin with a short review. In IP networking, packets are forwarded from one router to another, each step known as a hop. Every IPv4 packet contains a field called time to live or TTL, which is called hop limit in IPv6. That field is commonly initiated at 64 in IPv4, and each time a router forwards an IP packet, it reduces this number by 1 to 63, 62, etc. until 1n. When it reaches 0, the router discards the packet and sends back an ICMP packet announcing a time exceeded message to the sender, including part of the original packet so the sender knows what failed. Traceroute makes use of this mechanism. Let's look at an example of how ICMP works. Traceroute sends a series of packets toward a destination, starting with a TTL of 1, and each time a router forwards an IP packet, it reduces this number by 1 so the first router discards the packet and returns an ICMP time exceeded message. Traceroute records the address of that router and the round-trip time, RTT, the time between sending the packet and receiving the ICMP reply. Next, traceroute sends another packet with a TTL of 2. It goes through the first router, however the second router discards it, sends an ICMP, time exceeded message, and again the RTT is recorded. This process continues, increasing the hop limit by 1 each time, until the destination is reached or a predefined hop count limit is exceeded. The result is a list of routers that form the apparent path to the destination. However, traceroute has limitations. It only detects devices that decrement the hop limit, that is, routers working at the IP layer. Intermediate non-IP segments, such as MPLS, ATM, or VPN tunnels, remain invisible, even though packets may pass through them. Another limitation involves round-trip time accuracy. Traceroute measures the total time for the packet to travel forward and for the ICMP reply to return. The return path may differ from the forward path, possibly taking a much longer route. For example, a traceroute from Germany to Portugal might show normal RTTs for Frankfurt and Paris, but an unexpectedly high RTT for Madrid if the returning ICMP packet takes a transatlantic detour. And finally, Lisbon. Therefore, RTT values in traceroute should always be interpreted with caution. Traceroute operates by sending packets with incrementally increasing hop limits. Each router that discards a packet generates an ICMP, time exceeded message, revealing its IP address. Non-IP networks are not visible in traceroute results. Round-trip times can be misleading because the return path may differ. Traceroute is a valuable diagnostic tool, but it should never be used in isolation when analyzing network performance or connectivity issues. Thank you for following this last Networking Basics 2 video and see you in coming courses of the Interconnection Academy.